Okay, so in order to substitute this I, so kita akan ambil daripada the first equation here, daripada V1. So kita akan dapat I is equal to V1 divided by R1. And then you substitute this one to here. So V total is equal to V1 divided by R1 times with R total. And then because our aim here is to find the voltage at specific resistance, specific resistor, so kita kena tulis the formula, rearrange the formula in terms of V1 is equal to what? Okay, so kita akan rearrange here. V1 will be equal to V1 will be equal to R total. Okay, wait. Let's substitute this R total. So R total dekat sini adalah R1 plus R2. Okay, and then kita rearrange, kita akan dapat V R1 divided by R1 plus R2. So the equation, the formula untuk potential divider will be R1 divided by R1 plus R2 times with voltage supply. So this will be the formula untuk potential divider. So without finding the value for I, because as I said before, kalau kita guna Ohm's law, we need to find what is the value for I first in order to find V1. So in order to find I, kita kena cari this one dulu. Okay, now untuk potential divider, we don't need to find I anymore. Kita terus masukkan that value here. Sebab usually memang kita akan dibagi R1, R2 dan voltage daripada battery. Okay, so this one adalah untuk cari V1. So in order to find V2, in order to find V2 senang je lah. Yang kamu kena ubah, kamu kena ubah this one only. So kalau dekat sini V1, dekat atas sini will be R1. So in order to find V2, it will be R2 divided by R1 plus R2 times with V. So this potential divider only apply on series circuit. Okay, kita boleh guna untuk series circuit saja. So kalau nanti kita akan dapat circuit tu in terms of parallel, we need to simplify the circuit into a series circuit. This one here. So dekat bawah ni dia akan sentiasa total resistance. If we want to find V2, kat atas akan jadi R2. Di bawah akan jadi total resistance and times with the voltage. Okay, jelas the formula here?
Jelas, Miss.
Jelas, Miss.
Okay.
Jelas, Miss.
Okay, so kita akan tengok terus kepada example ya. Okay, untuk potential divider dia sangat simple sebenarnya benda ni. So basically apa yang kamu dalam chapter 3 in order to find voltage kita boleh guna dua method. Satu Ohm's law, satu lagi potential divider. So Miss galakkan kamu untuk guna potential divider lah sebab dia lebih senang. Okay. So dekat sini example dia sangat simple. So we are given a battery here 12 volt and connected to 8000 ohm and 4000 ohm. So dekat sini this is a series circuit. Now we want to calculate the output voltage. So output voltage adalah this one. Maksudnya what is the voltage across these 2 points. So dia letak sini point, these 2 points. Maksudnya what is the voltage across this resistor. Okay, first of all let's label dahulu. So this one R1, this one R2. So in order to find V out, because you want to find V out, right? So what is the resistor across this V out, which is R2. So R2 and then divided by the R total. R total kita ada 2 saja. And then times with the voltage supply here. And then you just masukkanlah that value 4,000 divided by 8,000 plus 4,000 times with 12 volt. And then kamu akan dapat
Four.
4 volt. So this one sangat simple. Kamu just terus masukkan dalam formula yang dibagi. Okay, so soalan kedua. If a voltmeter of resistance 4,000 ohm is connected across the output, determine the reading of the voltmeter. Okay. So now dia cakap there's a voltmeter with resistance 4,000 ohm connected across the output. So maksudnya dekat mana dia connected? Is it here? In between? Anyone ada idea dekat mana? Dekat mana?
Dekat V out.
Dekat V out. Because it says here it is connected across the output. So maksudnya the new circuit so this is the original circuit, right? We have 12 volt, R1, R2, and then we connect another resistance. So we connect another resistance here. They must be connected across the output because our output is here, so kita lukis resistance tu dekat situ lah. So kita label this one sebagai R3. Now we want to find what is the reading of the voltmeter. So basically this is also a voltmeter with a resistance. So we want to find what is that reading of the voltmeter. Okay, this one simple saja. We can still use the potential divider method, but as I said before, in order to use this potential divider method, we need to simplify the circuit into series. As you can see here, these two resistors are connected in parallel. So kita kena simplify lah dahulu these two resistor supaya dia boleh jadi macam ni semula. So in order to simplify, R23, which is, kejap berapa tadi? R3 here. Oh, this one is 4,000. Ini kamu akan dapat berapa? R23.
Miss.
2,000 ohm. So kita sudah simplify this tu, maksudnya sekarang ni our resistor is like this. Okay, dia akan jadi R23 lah dekat sini. And then we still want to find what is the V out here. So still using the same method, V out will be equal to R23 divided by R1 plus R23 times with volt. So here 2,000 divided by 8,000 plus 2,000 times with the voltage. So voltage dia tidak berubah, still 12 volt here. It will be equal to
2.4.
2.4. Okay, so here you can see kalau kita tambah another resistor in parallel with the first one, the voltage will decrease. So voltage akan decrease lah kalau kita tambah another resistor. Because original voltage kita adalah 12 volt. And then dia kena bagi pula dekat resistor ni. And then dekat resistor ni yang ada 2 lagi. Okay, ada soalan so far?
Tiada, Miss.
Okay, kalau tidak soalan, let me proceed to the next example. Okay, so this example sama juga macam soalan yang tadi, but we are not given the circuit. Okay, so here we are given the resistor 3 ohm and 6 ohm are connected in series with 12 volt battery of negligible internal resistance. What is the potential difference across 3 ohm and 6 ohm resistor? So we are not given the circuit, we can try to draw the circuit. So we have battery 12 volt, and then they are connected to resistor 6 ohm and 3 ohm in series. So sama lah macam yang tadi tu. So here is 3 ohm, this one is 6 ohm. And then we want to find the potential difference across 3 ohm and 6 ohm. Okay, untuk yang belum tahu lagi, potential difference and voltage is the same thing, okay? Kamu jangan confuse lah apa beza potential difference, apa beza voltage. It's basically the same thing. So if we, the question asks to find what is potential difference across 3 ohm, maksudnya the voltage across this resistor. So here let's label this one R1, R2. So we want to find V2 and V3. Using the same method of potential divider, V2 will be equal to R2 divided by, sorry here, V1, V2. Equal, times with V. And then V1 akan sama dengan R1 divided by R1 plus R2 times V. Kamu akan dapatlah the value 6 divided by 3 plus 6 times with 12. This one 3 divided by 3 plus 6 times with 12. So you should get V2 is equal to 8 volt. Okay, cuba double check. V1 should be equal to 4 volt. Okay, semua dapat jawapan ni?
Dapat Miss.
Dapat Miss.
Dapat Miss.
Okay, so this one, you can see it's very simple kan, sangat senang sebenarnya untuk cari voltage across a resistor without finding the current first. That's why after this, kalau kamu jumpa mana-mana soalan bentuk macam ni, you can use straight away using potential divider. Unless soalan tu mention, you need to find the voltage using Ohm's law. So kena baca soalan lah betul-betul sebab kadang-kadang soalan dia spesifikkan what method you need to use. Kadang-kadang pun dia memang ada bagi tahu you need to use potential divider. So kalau kamu guna Ohm's law, tidak akan dapat markah dekat situ lah. Okay, so kena tahulah, kena tahu bezakan macam mana mau cari guna Ohm's law, macam mana mau cari guna potential divider. Okay, so kita akan bincang soalan tutorial. Since ada beberapa soalan yang kita belum buat lagi, kamu just buat soalan a few question, right? Okay, before masuk part 1, kita masuk yang where is it? Okay, soalan 8 dan 9 dahulu, which is soalan berkenaan dengan potential divider. Okay, so here we are given figure 3.6. Given that the resistance 1 is 3 ohm, this one is 2 ohm connected to a battery of 15 volt. And okay, so basically kat sini salah, dia sebenarnya connected in 12 volt. Kenapa 12 volt kat sini? Okay, kita okay, abaikanlah this one. Kita tengok je circuit yang dibagi. So here we have 15 volt connected in series with resistance 1, resistance 2. Okay, now we want to find what is the potential difference across R2, which is here. Because here we connect to a voltmeter, so kita boleh tahulah apa reading the voltmeter here. So soalan A, we want to find V2. Again, using the same method, V2 will be equal to R2 divided by R1 plus R2 times with the supply voltage. So here 2 plus 3 times with 15 volt. Okay, dapat berapa?
6.
6 Miss.
6. Okay, you will get 6 volt. Okay, this one's boleh kan? Simple je. Okay, soalan B. The resistor 1 is now replaced and calibrated with a variable resistor RV. What would be the resistance of RV if the reading of the voltmeter is 5 volt? Okay, so resistor 1 dekat sini, kita replace with RV, which is variable resistor. Maksudnya resistor yang kita boleh ubah dia punya value resistance. Okay, so here, so ni tiada sudah, kita akan ada RV. Okay, so we want to find what is the value of RV if the reading of voltmeter is 5 volt. Okay, but here, okay, sama juga lah, voltmeter dia still di sini kan, maksudnya sekarang ni kita punya voltmeter V2 adalah sama dengan 5. So soalan V, V2 will be equal to 5 volt sebab dia cakap reading of the voltmeter is 5 volt. So voltmeter kita di sini, this one will be equal to V2 will be equal to 5 volt. Now we want to find what is RV. So it's using the same method. Okay, instead of R1 di sini, because we have replaced the first resistance with RV, and this is what we want to find. So you just masukkanlah V2 sama dengan 5. Yang lain still kekal sama. Times with 15. So RV will be equal to
4.
4 ohm. Kamu kira kan, jangan tengok jawapan dekat sini je. Make sure you double check the answer. Okay, ada soalan so far?
Tiada, Miss.
Tidak Miss.
Tiada Miss.
Okay, kita tengok the last one. Okay, does the power dissipated by R2 increases, decreases, or remain the same? Okay, so basically, first situation, dekat situation A di sini, kita ada, kita sudah kirakan the voltmeter reading here is equal to 6 volt. And then, second situation, we replace with another resistor. and then we replace with another resistor, the voltmeter reading will be equal to 5 volt. Okay, so kita compare dua situation ni. Adakah the power at this resistance increase, decrease, or remain the same? How can we know? Macam mana kita mau tahu dia increase ke, decrease, ataupun remain the same? Anyone ada idea?
Calculate the power, Kamis.
Calculate the power. Okay, so the easiest way is we calculate the power lah, just to make sure. Okay, so what is the formula for the power?
P equals to IV.
P equal to IV. Okay, so here, because we want to find the power at specific resistor, right? R2 here. Since R2, since V2, we have the value, this one and this one, but we don't have the value for I. Okay, kita ada value untuk I. And we have another formula yang tidak memerlukan value untuk I kan, untuk power. What is that formula? There's another formula.
E
P
square
equals to
over
V square over R.
Okay, P is equal to V square over R. And then we want to find P1. Sorry, is it P1? Sorry, P2, because the power at resistance 2. Since we want to find P2, so here will be V2, here will be R2. So we calculate P2 for the initial situation di mana V2 sama dengan 6 volt. We just masukkan lah. R2 will be equal to, dan kamu akan dapat
Eighteen.
18. So 18 watt, and then apabila V2 is equal to 5 volt, you will get P2 will be equal to
12.5, Miss.
12.5 watt. Okay, so kita tengoklah, this one is initial situation, this one is final. So from here, as you can see that P final is less than P initial. So maksudnya the power will be decreased lah. Sebab dia tanya what is the, does the power decrease, increase, or remain the same? So the power will be decreased. Okay, semua dapat?
Dapat,
Dapat,
Miss.
Miss. Dapat, Miss.
Okay, so can I continue to the next question?
Yes, Miss.
Okay, kita tengok question number 9. Okay, this one soalan tutorial 3 ya. Just in case ada masih ada yang blur. Ni soalan tutorial 3, so number 9. Okay, so here we are given 5 resistor connected to a power supply of 40 volt. So kita ada resistor, ada 5 di sini. Let's label the resistor first. Okay, the question asks to calculate the potential difference between points. So we are given points P, Q, R, S, T. Okay, kita tengok satu-satu. The first one is calculate the potential difference between point P and Q. So P and Q. Maksudnya the voltage across this one is equal to what? Okay. So before this, we learned in 3.2, I think. to use the Ohm's law method. So in order to use the Ohm's law method, we need to find current. Tu je sebenarnya beza Ohm's law dengan potential difference ni, you need to find the current. Okay, so now I want you to find that potential difference using the potential divider. So how do we find using the potential divider here? What's the first step?
Make it into series kan, Miss?
Okay, we need to simplify the circuit into series circuit. Since kita punya circuit ni sekarang, this one is parallel, this one is parallel. So kita kena simplify dahulu. Okay, so we need to simplify so that the circuit will look like this. Maksudnya 3 ni kita kena kira, 2 ni kena kira, 3 ni kena kira. Akan jadi this one R 1, 2, this one R 3, 4, 5. So since these two are connected in parallel, these two are connected and parallel juga. So you just kira dahulu R12 will be equal to 1 over 8 plus 1 over 10 equal to
4.44.
4.44 ohm. And then R2 3, 4, 5 1 over 5, 1 over 18, 1 over 25.
.38.
3.38 ohm. Okay. So the circuit will look like this sebab kita sudah simplify. And then sini point P, this one Q in between. Then dekat sini adalah point T. Because we want to find VPQ, right? The potential difference between point P and Q. So meaning that we want to find this, the voltage at this specific resistance. So using the potential divider formula. So here will be R12 divided by total times with the power supply here. What was it? 40 volt. And then you just masukkan lah 4.44 divided by 3.38 plus 4.44 times with 40. So kamu akan dapat
22.71.
22.71. Okay, semua dapat value ni?
Dapat, Miss.
Dapat, Miss.
Okay. Next one. Calculate the potential difference between point Q and T. So between point Q and T, here. Maksudnya, what is the voltage across here? VQT. Okay, so this one, what method can we use to find VQT here?
Tukar dia punya bintang di atas tu.
Okay, so kita boleh guna the same method, potential divider here. So just tukar je lah kan dekat sini because you want to find the voltage across 3, 4, 5. So VQT will be equal to R345 divided by R12 plus R345 times with V. So here will be 3.38 divided by 4.44 plus 3.38 times with 40. So VQT will be equal to
17.29.
17.29 volt. Semua boleh follow? Yang lain?
Boleh, Miss.
Okay, so there is also another method we can find VQT. Macam mana? Ada yang ada idea? Macam mana kita mau cari VQT using another method?
Kita nak cari dia punya
Dia punya
current.
Miss. Total volt tu tolak je voltan PQ tu.
okay. So another method is we need to find the current lah. Tapi that one will be quite long. So Miss tidak galakkan. Sebab nanti kamu akan confused. So another easiest way will be kita just tolak daripada total voltage. Since dekat sini adalah 40, right? So V total will be equal to V PQ tambah dengan V QT. Since tadi kita sudah kira V PQ, so in order to find V QT, we just tolak saja. So here, or another method we can find is V QT equal to 40 minus 22.71. You will get the same value lah, 17.29 volt. Okay, so kalau soalan macam ni dia tidak spesifikkan method apa yang kamu boleh gunakan, we can use this method ataupun terus gunakan this one as long as you can find that value of VQT. Okay, boleh?
Boleh Miss.
Boleh, Miss.
Okay. Okay, next one. We want to find what is the potential difference between point R and S, which is basically point R and S ni adalah across the resistor number 3 here. So how do we find this one? Anyone?
Series kan sama Miss.
Apa dia?
Series QT tu tak sama kah?
VQT. Okay. So VQT tadi kita sudah dapatkan. Now we want to find what is VRS. So since these three are connected in parallel, so dia akan jadi sama lah kan?
Yes.
Okay. So kamu kena ingat ya dekat sini, the voltage across the resistor here untuk parallel dia akan sama. So R3, R4 and R5 will have the same voltage. So meaning that here VRS will be equal to VQT, which is equal to 17.29 volt. Okay, semua boleh nampak macam mana kita dapat the same answer? Ada soalan?
Dapat, Miss.
Okay. Last one. Calculate the current flowing from point R to point S. So the current flowing at this resistor number 3. Maksudnya we want to find I3. Okay, soalan D, we want to find I3. So in order to find I3, okay, yang lain ni semua mestilah the value of the resistance at that resistor and the voltage at that resistor. Okay, so voltage dekat RS tadi, okay, kita sudah dapatkan, which is equal to this one, 17.29. So you just masukkanlah untuk dapatkan that one. So V3 here is actually the same as VRS. 17.29, betul ke tu? Yep.
Betul, Miss.
17.29 equal to I3 times with the resistance 5. So I3 kamu akan dapat
3.458.
3.458 ampere. Semua dapat?
Dapat, Miss.
Okay, ada soalan so far untuk potential divider?
Tiada, Miss.
Okay, tiada soalan. So, daripada sini kamu boleh nampak lah. Kalau kita compare dengan calculation yang kita buat sebelum ni, menggunakan Ohm's law, dengan menggunakan potential divider lebih senang, lebih straightforward. Kita tidak perlulah untuk cari banyak kali. Okay, so just ingatlah di sini, if the question specific dia tanya, find the voltage using potential divider, kamu kena gunakan that method. Kamu tidak boleh gunakan another method. Tidak boleh gunakan Ohm's law. Kalau dia tidak spesifik, then you are free to use any method that you are comfortable with. Tapi Miss galakkan kamu guna potential divider lah. Because it's very easy. Okay.
Miss,
Yes.
kalau contohnya dalam series tu ada 3 resistor,
So maksudnya dekat bawah ni akan ada another tambah lah. So dia dekat bawah ni adalah total resistance. Here. The formula dekat sini adalah total resistance kan. So berapa banyak resistance dekat dalam tu, kita akan tambahlah semua resistance.
oh okay Miss, thank you.
Okay, but for your syllabus, Miss nak pernah jumpa lagi lah ada 3 resistor untuk kalau gunakan potential divider. But kita tidak tahu kan, anything can be possible untuk soalan syllabus kamu. So you just ingatlah, this one dekat bawah ni adalah total resistance. So if we have another, let's say if we have another resistor here, RA, so kamu kena tambahlah dekat bawah ni, tambah RA. Okay, macam tu je. It's very simple. Okay, kita akan bincang soalan tutorial yang kita belum bincang lagi, which is soalan 3. So kamu sudah buat soalan 1, 2, soalan 6, 7 I think. Ada 4 soalan. So misalkan kita akan bincang soalan yang selebihnya so that you don't have to do it lah. Okay. So let's look at this question number 3. So we are given figure here with EMF 15 volt, internal resistance 4 ohm and connected to another resistor of 6 ohm. So here is the battery. This one adalah internal resistance of the battery and then this is another resistor. First question, we want to find what is the reading of ammeter and voltmeter in the circuit above. So voltmeter dia letak across the battery and the internal resistance and the ammeter here. So maksudnya we want to find what is the voltage and what is the current in this circuit. So how do we find this one? Anyone ada idea? We want to find V and I.
Pakai Ohm's law.
Pakai Ohm's law.
Yeah.
Okay, so kita gunakan Ohm's law. V is equal to IR. Okay, but because we want to find what is V and what is I, so how do we use Ohm's law to find this value? Maksudnya, in order to use this formula, kita kena ada either V ataupun I.
V1 sudah diberikan.
V adalah sama dengan
15 kan? Macam mana
okay, V
itu?
sama dengan 15. Okay, I is what we want. So, what is the value for I here?
10.
10.
Yeah.
Right. Okay, so because dekat sini kita ada 2 resistor, right? which is equal to 6 plus 4. So if we use here total, dekat sini pun mesti ada total. So I will be equal to
1.45.
1.45 ampere.
1.5 siya.
1.5. Okay, semua dapat?
Dapat, Miss.
Dapat,
Okay.
Miss.
So, kalau kita gunakan this method, right? Gunakan Ohm's law. Maksudnya resistor dekat sini, internal resistance dekat sini kita anggap dia another resistor lah. Dan dia adalah in series with this resistor. So, we just find the total of that. And then here will be the voltage from the battery. Okay, so now kenapa soalan ni minta the value for the voltmeter pula, which is the value for V. How do we find this one?
Sebab voltmeter tu ada rintangan dalam daripada bateri.
Okay, so because voltmeter ni kamu kena tengok jugalah spesifik kan. Voltmeter ni dia dekat mana dia diletakkan. So since voltmeter ni across these 2 point, which is kita ada battery dan kita ada another resistance. So we can find this one, this value for voltmeter using the formula in 3.4 I think, which is using the EMF formula. What is that formula? Value untuk EMF.
V equals to
V.
EMF minus IR.
Minus IR. Okay. So basically konsepnya di sini kan, kalau kita anggaplah tiada dulu voltmeter ni. And then kita anggap this resistor is just another resistor, bukan dalam battery. So kita tahu 15 volt akan sama dengan the voltage across this one. The voltage across this one. So VR plus dengan VR. Maksudnya voltage dekat sini tambah dengan dekat sini kita akan dapat 15 volt. So basically that formula of this one is the same thing. Since we want to find this voltage, so basically voltage ni adalah across these two. Bila dia across these two, that's why the EMF kena tolak dengan the voltage across the small resistance. Because the voltage across here, across these 2 point will be the same with the voltage across these 2 point. Sebab dia punya titik ni kan akan sama. So here kamu akan dapat EMF kita masukkan 15 minus dengan I yang kita sudah dapat tadi, times with internal resistance 4 ohm. So the value for V will be equal to
9.
9 volt. Semua dapat?
Dapat, Miss.
Dapat, Miss.
Dapat.
Okay. Soalan seterusnya. Explain why is the voltmeter reading different from the EMF of the battery. Okay, kenapa voltmeter reading dekat sini, which is kita sudah dapat tadi kan 9 volt, dia tidak sama dengan 15 volt. Okay, I need someone to explain. Basically, Miss sudah explain tadi, but I need another person to explain. Hamizan ada? Hamizan tidak. Syazwani? Syazwani, are you there? Syazwani boleh dengar Miss cakap?
Ya, Miss.
Okay, Can you explain why is the voltmeter reading different from the EMF of the battery? So voltmeter reading kita tadi kita sudah kirakan which is equal to 9 volt, but battery is 15 volt. Kenapa dia tidak sama? Boleh Syazwani? Tak dapat. Okay. Tak apa. Ada yang tahu? Yang boleh volunteer? Mau explain?
Jawapan saya, Miss.
Apa dia?
Potential energy is used to flow electron throughout the resistor.
Potential energy is
Used
to
to make electron flow throughout the internal resistor.
okay, okay, betul lah tu. The explanation is betul lah. So basically apa yang Azmi cakap tu, the potential energy, because bila kita supply energy right daripada the battery, we supply, and then apabila supply the energy dekat, setiap kali dia lalu dekat resistor ni, dia akan ada potential drop. Okay, dia akan ada potential drop di sini. Okay, so depends kepada, sebenarnya dia akan depends kepada the position of the voltmeter. So if let's say Miss buat macam ni kan, the circuit, and then I put the voltmeter here, and this one is 15 volt, R1, R2. So if I put the voltmeter here, there is no resistor dekat sini, this voltmeter dia akan baca 15 volt. Okay, dia akan baca 15 volt. But if we put a resistor, kita ada another resistor here, dia tidak akan baca 15 volt. Sebab kenapa? Sebab ada potential drop di sini. Okay, there is a potential drop. There is a resistor. So bila ada resistor, mesti ada potential drop. That's why, bila ada potential drop, dia kena tolaklah daripada value of 15. So dia mesti kurang daripada the supply voltage. Okay, boleh nampak ke bezanya di situ?
Boleh, Miss.
Boleh, Miss.
Okay, so as long as you understand the concept lah. Because when we, it depends on where we put the voltmeter. If we want to put the voltmeter here, across R1 only, maksudnya voltmeter ni dia akan baca between these 2 point. And dia mesti kurang daripada 15 volt. Dia tidak akan sama sebab dia adalah series circuit. So every time battery dia supply the voltage across the circuit, bila dia sampai dekat sini, so basically this one is just analogy lah. So 15 volt ni dia bawa lah kan, dia jalan, and then bila dia sampai dekat resistor 1, maksudnya dia bagi sedikit value of that 15 volt, and then dia jalan lagi, lepas tu dia bagi lagi. That's why kita panggil dia sebagai potential drop. Maksudnya dia bagi voltage tu. It's just the analogy lah, but the basically yang bergerak adalah electron, not the voltage, because voltage is just a force. Okay, voltage ni adalah satu force, electromotive force, yang menggerakkan elektron di dalam circuit. Okay, ada soalan so far? Boleh Miss teruskan?
So far no question, Miss.
Okay. Okay, I continue with the next one. We want to find how much energy will be dissipated by the resistor R after 65 seconds. Okay, so soalan ni dia gabung dua subtopik sebenarnya. So kita akan gunakan Ohm's law dekat dalam soalan ni, dan juga kita akan gunakan the subtopic energy and power. So we want to find what is the energy by the resistor R, which is this resistor after 65 seconds. Okay, we want to find energy, right? Soalan C. Okay, apa formula untuk energy?
PT.
I VT, and given that T is equal to 65 second. So I dekat sini kita sudah ada 1.5 because dia adalah series circuit, so 1.5 for the whole circuit. And then the V dekat sini adalah which one? Which value of V?
9.
9. Macam mana kamu tahu dia adalah 9? How do you know if it's 9? Bukan 15?
Dia minta potential difference untuk resistor R.
Sorry Azmi, Miss nak dengar lah suara kamu.
Dia minta potential difference untuk resistor R.
Okay, because dia minta untuk this one. Okay, because we want to find the energy specific dekat sini kan. So kalau the energy specific dekat sini, voltage pun yang dalam formula ni mestilah yang voltage di dekat resistor ni. So kita tahu if we, macam Miss cakap lah tadi kan, if we calculate the voltmeter, if we place the voltmeter here and we get 9 volt, meaning that the voltage here, 9 volt, will be equal to the voltage here also. So the potential difference across R is also 9 volt. And then you just masukkan 65 second. So energy will be equal to
877.5.
877.5. What is the unit for energy?
Joule.
Joule. Okay,
Wow.
semua dapat?
Dapat Miss.
Dapat Miss.
Okay, ada soalan so far?
Miss yang volt tu kan. Cuba Miss scroll atas dulu tengok soalan. Kan Miss cakap atas tu 9 volt, bawah tu pun 9 volt. Jadi 6 volt lagi pergi mana Miss?
Basically, because dekat atas ni adalah the voltage across these two, across the resistor and across the battery. So basically 15 dekat sini 9 kan, basically dekat sini adalah 6 sepatutnya. That's why 15 tolak 9, kamu akan dapat 6 kan, 15 tolak 9 dapat 6. Boleh faham tak tu? Okay, contohlah. Okay, if I buat macam ni. Okay, so tadi the voltmeter is here. So basically we find the voltage across this resistor 6 ohm, which is sama dengan 9 volt. Okay, if we want to find the resistor across this 4 ohm. Okay, can you find first what is the voltage across this 4 ohm? Basically kamu akan dapat 1.5 darab dengan 4. 1.5 darab dengan 4 akan dapat 6 volt kan? Betul kah?
Betul Miss.
Okay, so dekat sini akan dapat 6 volt. So since voltmeter ni sebenarnya dia measure 2 points. Dia measure points dekat sini dengan points dekat sini. So points dekat sini dengan dekat sini kita akan dapat 9 volt. So basically dia pun voltmeter ni juga akan measure point 2 di sini, which is sama juga 9 volt. So basically disebabkan this one dia supply voltage, so dia kena tolak dengan 6 volt. 15 tolak 6 kita akan dapat 9 volt kan? Boleh faham ke tu?
Faham, Miss.
Okay, so bila that's why this voltmeter dia akan kira 9 volt walaupun kita letak di atas sini, which is this one here lah. Boleh nampak macam mana dapat daripada mana dapat 6 volt tu?
Dapat, Miss. Thank you, Miss.
Okay, kalau tak jelas beritahu lah. Yang lain boleh faham?
Boleh, Miss.
Boleh faham,
Boleh,
Miss.
Miss.
Okay. Okay, let me explain in terms of parallel. Okay, so kita ada contoh lah, we have resistor in parallel. So here 10 volt. Kamu just ingat saja kan, you just remember that okay, the voltage across all of this resistor will be equal to 6 volt. Semuanya akan, the voltage across this one, V1, V2 and V3. Kita akan samakan dia. Sebab kita tahu kalau dalam parallel, voltage akan sama. Kenapa dia sama sebenarnya? Sebab the voltmeter, kalau kita letak, dia adalah between these 2 point. So between these 2 point, dia sentiasa sama. Okay, dia akan sentiasa sama. So kalau Miss letak another resistor di sini. Okay, Miss letak another resistor dekat sini. So voltmeter ni masihkah dia baca 10 volt?
Tidak.
Tidak, dia tidak akan baca 10 volt sudah. Sebab kita ada another resistor here. So, let's say lah, okay, Miss just letak number lah. Let's say dia baca maybe 8 volt lah. Sebab kita ada another resistor here. So, 8 volt ni still sama, equal to V1, equal to V2, equal to V3. So, voltmeter ni basically dia measure between 2 points. Point A and point B. Kalau point A dan point B ni is the same thing here. So they all will measure the same voltage. So that's the concept lah kenapa voltage dekat dalam parallel dia sama, tetapi bila dekat dalam resistor dia tidak sama, dalam series dia tidak sama. Because in series we have something like this, right? So when we have 10 volt and then kita letak voltmeter and then kita akan measure. So between these 2 point pun dia akan measure 10 volt sama sebab dia measure between point yang sama. Okay, tetapi so here V1, V2. Disebabkan dia resistor, dia akan ada voltage drop. That's why 10 volt akan sama dengan V1 plus V2. 10 volt ni dia bagi dekat sini, dia bagi dekat sini. Okay, it's something like that lah kamu punya konsep untuk series dan parallel. Okay, boleh?
Boleh,
Soalan?
Miss. Faham.
Ada soalan?
Tiada, Miss.
Okay, hopefully kamu faham lah konsep tu. Okay, let's move on to the next question. Okay, so habis sudah kan soalan ABC. Okay. So
Yes.
soalan yang yes.
Miss,
Ya, ada soalan. Apa dia soalan dia?
yang soalan tadi yang B tu, Miss, macam mana letak dalam yang proper ayat?
Okay, letak dalam beberapa ayat. Soalan B. So we can say that the voltmeter, sebab dia tanya why is the voltmeter reading different from the EMF of the battery. So basically voltmeter ni is measuring the terminal voltage. Maksudnya dia read the terminal voltage between 2 point. So there is a difference in potential energy between, sorry Miss punya tulisan boleh faham ke tu?
Boleh Miss.
Boleh akan baca. Between the terminal voltage and the EMF. Okay, semua dapat?
Dapat Miss.
Okay. Let's look at the next question number 4. A cell of EMF 1.5 volt and internal resistance 1 ohm maintains a constant current of 0.5 ampere in an external circuit. When an electric charge of 2 coulomb flows in the external circuit, calculate the thermal energy dissipated from the cell, energy dissipated from the external circuit, the total energy supply by the cell. Okay. So here we have EMF. Kita ada EMF 1.5 volt. And then kita ada internal resistance 1 ohm. And then a constant current of 0.5 ampere. So EMF. And then internal resistance and current 0.5 ampere. And then we are also given an electric charge. So value for Q, 2 coulomb. Okay, first we want to find the thermal energy dissipated from the cell. Okay, so keyword dia dekat sini adalah daripada cell. So what is the cell here? So cell ni dia sebenarnya merujuk kepada mana? Kepada siapa? Kepada EMF, kepada battery. Okay, basically cell di sini adalah the battery. So kamu kena take note lah this one sebab kadang-kadang soalan dia tidak bagi spesifik. Dia akan guna nama lain. So cell here is the battery. Okay. What is the formula for energy?
IVT.
IVT, right? So energy is equal to I times V times T. Okay. So here we are given the value for I. Kita sudah ada I sebab dia cakap constant current. So maksudnya dia adalah series lah. Okay, dia adalah current yang sama throughout the circuit. So we have I. Okay, we don't have V and T. V di sini adalah voltage drop in the cell. Since kita punya cell ni ada resistance. Okay, biar Miss lukislah sini. So we have internal resistance here. So the V here, kita tidak boleh terus ambil 1.5 volt. So how do we find this one? Since V adalah sama dengan IR. Is it? Sekejap eh.
Miss,
Yes.
bukan guna yang EMF minus IR tu kak?
EMF minus this one, V is equal to E minus IR. So kamu akan dapat 15 minus 0.5 darab dengan 1. Okay, dapat berapa?
Fourteen point five watts.
Oh, sorry, berapa dia? 14.5
14.5 watt.
volt. Okay. So here was 0.5. Okay, wait. Before that, we don't have value for T. Okay, kita ada value untuk T kan? So we can find the value for T. How do we find value for T?
Miss,
Yes.
yang EMF tu bukan 1.5 ke?
Oh, 1.5 kah? Sorry. 1.5. So maksudnya dekat sini 1.45. Is it? Betul kah?
1.
Oh, check.
1.
1 jam.
1 jam. Okay. Sekejap ah. Okay, 1 jam. So now we want to find what is the value for T.
Q equals to IT.
Q is equal to IT. So Q kita sudah dapat. I is 0.5 times with T. T will be equal to 2 divided by 0.5 4 second, is it?
Yes.
Betul kah 4 second?
Betul, Miss.
Okay. Wait, before that, I think ada silap lah di sini. Apa silap dia?
Di mana, Miss?
This one, you shouldn't get 1 volt.
Itu nak perlu, saya nak pakai yang E minus IR.
I think, wait.
Pakai Ohm's law, check.
Okay, so V di sini adalah actually, sorry ya, V, because we want to find V in the cell, right? In the battery. So V here is actually just the voltage drop across the internal resistance. That's why kita tidak boleh gunakan this one sebab dia akan kira voltage across these two. So we use the Ohm's law. V is equal to IR, di mana I dekat sini adalah 0.5. Dan this one will be the internal resistance, which is 1. So kita akan dapat 0.5 volt. So here you should get 0.5 times with 0.5 times with 4 second. So E cell will be equal to 1 joule. But I'm still not sure kenapa kita guna V this one instead of this one. Okay, nantilah Miss cuba brush balik Miss punya knowledge. Later I will tell you why how do we know if we use this one or this one. Ataupun ada sesiapa yang tahu?
Saya rasa Miss yang one ni volt kepada liter di luar. Yang 0.5 ni dilesap oleh resistor.
Okay, is it that one?
Macam juga yang di atas tadi tu, yang 6 volt tu dilesap oleh internal resistor.
Because I don't understand why. Kalau kita mau cari cell kan for the battery. So why do we use the voltage on the resistor only instead of the voltage across the battery? Okay, sorry lah Miss, bingung sudah. Dapat kita move on dulu. Sorry guys, kita move on dulu to the next one. We want to calculate the energy dissipated by the external circuit. Okay, now the external circuit. So energy by the external circuit. E is equal to IVT. Okay, we can either use this one. Okay, E is equal to IVT. Or we can use the total energy, di mana total energy, okay, total energy adalah sama dengan EIT, right? EMF times I times VT, which is also equal to the EMF at the cell tambah dengan EMF at the external. So this one at the resistor, this one at the battery. So maksudnya kita akan dapat this one, right? So EMF kita ada, I kita ada, T ada, E cell kita ada which is 1 joule. So kita boleh cari E external. EMF is equal to 1.5. I 0.5 T 4 second. It's 1 joule plus E external. So E external will be equal to
2.
will be equal to 2 joule. Okay. Ada soalan so far?
Jadi kalau ikutkan pendaraban tu dapat 3.
Dapat 3 kah?
Oh, lupa terlalu 1. Okay.
2 betul lah kan? So maksudnya this one kamu akan dapat 3. So this one ada 1 sini. So total kita akan dapat 3 joule. For the external kita akan dapat 2 joule. Okay, any questions so far?
So far no question, Miss.
Okay, so for this one, okay, nanti Miss cuba fahamkan semula. Miss bingung sudah kenapa kita gunakan this one or this one. Nanti Miss akan cuba tengok balik dekat mana yang Miss nak faham. So I will explain nanti. Okay, so last question. We just want to find E total, right? So E total is just 3 joule.